Hello, welcome to all. In this video we will simply explain how to analyze accelerometer data. Vibration analysis. I have developed a vibration analysis tool used to analyze acceleration data by using MATLAB script. MATLAB has an excellent set of graphic tools. Plotting a given acceleration data set from an Excel file as a result of the computation is possible with very few seconds. This software used to record the signal as a result to plot the graph to show the acceleration versus time, RMS versus time, and amplitude versus frequency, FFT, which in turn is analyzed by engineers to determine the health of the machine and identify possible impending problems like looseness, unbalance, misalignment, lubrication issues and more. The Excel data format for A column stored time in second and B column stored vibration data in G unit. Step to import the CSV data. Click the Application tool. Click the Import CVS button. Choose the CVS file format data. This is the time domain figure. This figure shows how a signal changes over time. Time is represented in the x-axis on a graph. Acceleration data represented in the y-axis on a graph. Unit is g meter per second square. Time is represented in the x-axis on a graph and root mean square value of acceleration data represented in the y-axis on the graph. Datatype. Datatype function are used to highlight the coordinates of a data point on the graph. Datatypes are small text boxes that display information about individual data points. Create datatypes by clicking on data points in a graph or using the datatype function. If we don't need datatype point, right-click. On mouse choose the delete the current data type, otherwise to choose the delete the all data type as result to remove all the data type on the graph. We can move to adjust the graph using the pan function. Restore the window size by default by clicking the home function. Images and PDF files are supported in most applications for documentation of representing the plot. To save a plot use the Export button in the Axis toolbar. The Export button supports 3 image formats, PNG, JPEG, and TIFF, as well as PDF files. We can deciding to place the file into the location. This is the frequency domain figure, how much of the signal lies within each given frequency band over a range of frequencies. Used to diagonalize the fault propagation in the machinery component. The prevention of potential damage and indicate the service requirement. Close plot button is used to close all open graph. We can calculate the frequency of the pinion and gear mesh. The pinion is coupled to an input shaft connected to a prime mover. The gear is connected to an output shaft. The shafts are supported by bearings on the gearbox housing. Now we can simply enter the input field as pinion shaft speed as RPM. No of teeth of pinion and gear wheel. After clicking the calculation button to show the result of the pinion and gear mesh frequency. Thank you for watching.